All right, this is Mel, and this is a brief tutorial from Chat with Data YouTube channel on how to use LangChain to build complex, simple AI applications for JavaScript on JavaScript or TypeScript. So this is a JavaScript, TypeScript beginner's tutorial for LangChain. You kind of think of LangChain as a framework that makes it easier to build these large language model applications. So let's jump into it. First of all, what is LangChain? So to understand what LangChain is, we have to understand the problems around building applications. So if you've ever tried to build one of these AI apps that we see popping all over the place where, someone plugs into the OpenAI API and you've got, apps that allow you to write, create images and do all these wonderful things. But particularly when it comes to text, you know that there's a lot of challenges. So one of them, for example, is the issue of scalability. So what do I mean? Well, if you jump into the playground, for example, we can see that, yeah, it's cool. We can effectively, because the playground is a simulation of when we use the API. So I could come here and say, write a tagline for my business, click submit, and that's going to pop out, something, right? Now, but when we jump into looking at the max length of basically how much can we send to the large language model per request, we're looking around 4,000 tokens. That's more or less, I think, three quarters of a token is a word, right? So you're looking about 3,800 words to squeeze in per request, and that's a combination of your prompt. So your prompt is the instruction you're giving the large language model, and the response have to combine together to more or less 3,800 words. And if you don't meet that, then you need to start to do things like chunking and splitting your text, because let's say, for example, you wanted to summarize a 10,000 word PDF or 10,000 word book, to 20,000, or you wanted to extract insights, right? Now you're running into issues where you need to split the text, and then how much do you split the text by, and then how do you make sure you don't lose context, and so on and so forth. So if you've ever tried to build, or you can imagine, that's very frustrating and very difficult to deal with. The second issue is you are probably going to get irrelevant and misleading information without proper context. What I mean is, when it comes to custom data that's relevant to your business, data that's relevant to your work, or something specific you're looking for that's real time on the web, these large language models are not going to necessarily give you the best results. So here, for example, this is me earlier tried to look at this particular method or of putting together a chatbot using LangChain. And this is the response that ChatGPT gave me. Was effectively is a natural language processing model, and LangChain is a blockchain, which is not true. Now it's talking about smart contracts and all these things that have nothing to do with LangChain. So if you've ever tried to use ChatGPT for specific things of your work or custom data or specific knowledge, you've probably been frustrated to see that it's not really tailored towards you. It's just very general. It's very good at general things, and that's what they were made for, so that we can quote unquote fine tune it for our specific use. The third pain point is around crafting, complex prompt workflows. So you can imagine this is very basic, but imagine if you had a situation where you wanted to describe, something a bit more, where you're providing some sort of an identity. You say, let's imagine you're a business owner based in New York. You have 20 years experience, building businesses, what you want to expand businesses in retail, what you want to expand to fashion, and blah 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 blah. Right? You can imagine like a prompt where you basically give an identity, and then after you give an identity, you probably want to give like instructions of what not to do or what not to say, and then you probably want to give examples, and you want to give context, right? So there's a lot that you can feed the model ahead of time to get a more precise result. The problem is, as I said earlier, it doesn't scale because it's difficult to do all of that precisely within the same chunk. But the other issue is it's just very complex to manage, because imagine all these different things are inputs from users, right? So you could have, this being a variable input, you could have this being a variable input. Then you have to deal with testing and logging and managing your tokens and your costs and all these things that are, problems as well. That's another issue. Then pre-processing and formatting unstructured data, which, the large language model is going to best understand text. The stores, which I'm going to talk about in a second, where we put the text in number format so that we can retrieve, also prefers this kind of clear text format. So if we're coming from the world of PDFs and images, we need to pre-process, we need to, even with text, we need to chunk it up, we need to make it in a way where it's easier and it's efficient to work with our data. And then the third, and then the final thing is the cost of APIs, right? As demand rises, the cost of the API increases as well because of inefficiencies in all these other areas. So now we understand what the problem is. Let's see how LangChain can help to solve. So as I said, it's building AI apps powered by custom data made easy. That's the most simple way I can explain it. So we're looking at use cases, question and answer documents, custom documents, ChatGPT for your data. Like I said, you have that chat experience, but it's tailored for your data. And then you've got personal assistants to use external tools. For example, you can be able to chain together instructions that, effectively a bot is able to go and search real-time data on Google, and then maybe use OpenAI to generate some sort of instructions or response, and then take that response and plug it into Slack, or maybe book your calendar for you, right? So there's so many use cases, and then you got summarization of large documents. So you can kind of think of LangChain as a library or framework to coordinate all these different use cases and all these different complexities that we spoke about earlier that were problems. And so these are the components of LangChain. So as I said, you got your prompts. So your prompts are the instructions to the large language model as to what to do. Then you've got the large language model itself. You got memory, the ability to memorize previous conversation. You got indexes where you store the data, document loaders, how you convert the docs to text. You got agents, which is where integration to external tools comes in. You got chains, basically chaining together all these different components, where the name LangChain comes from. So what does this all look like? For example, let's jump into their docs, right? So now this is the LangChain docs for JavaScript and TypeScript, which we're going to focus on in this tutorial. And what you can see up here is a search bar, right? So if I jumped in here and I said, okay, how can I help you? And I say, well, I want, how do I create a chain for a chatbot for my documents? Okay, and here we go. You can use LangChain to create One of them is conversation chain, which is pre-built, and it gives you the code, and it gives you verified sources to check it out. So you can see these are actual verified sources from within this website itself. And that's basically what is capable, what we're capable of doing now is basically you turn your docs, your website, your newsletter, your application, your database into this format that we can have a chat or conversation with. So this is basically what the power is, and you can see how this is way more precise than, you know, something like this. Okay, cool. So let's jump into the code, right? So we're going to start off first of all with a simple chain. So simple chain is effectively where we have an input from a user or just a general input, a query, just like we would with ChatGPT. And the large language model like OpenAI will take that query, process the query, and return a response. So here's the code base for a second. Let me just clear that. And so you can see the structure here. So we installed the library LangChain, which you can do by just simply doing npm install LangChain. I'll put all the instructions in the GitHub repo after this tutorial. But effectively, all we're doing is just like you typically would. You would initiate the model, put in the temperature or whatever the parameters you want to use, and then you get the response. Right. This is just the syntax using OpenAI. So in this case, I'm just simply going to go npm run start, and I'm going to go here. We're just going to do a basic call.ts. So I'm going to run through this. I already have my environment variables. My OpenAI key is already in play, and we're running, and we should see Paris. Okay, so we got the response back from the large language model that the capital city of France is Paris. Okay, cool. So that's a basic call. Now let's move over to another example. I'm going to go through two examples, but let's start with this one, where effectively we have a user. And instead of just simply saying, what is the capital city of France, where I'm the one who's going to hard code, this time we're going to make France variable. So it's going to be variable to what the user inputs. And this is not any different from a typical AI application. If you built one, you're always looking for a way to have your prompts, which is your instructions, but then you have pockets of those instructions that you want the user to be able to input, which customizes and makes it more tailored towards them. So the user is going to give an contribute here and be able to change the country. Then we effectively create this chain with the large language model, who then output. So it's basically identical to this, except the user, we have this variable here. And we can call this a prompt template, and we can call this the chain, right? So let's hop back to the code, and we're going to go to prompts. So LangChain has these prompt templates, as I explained to you earlier, that are effectively just these, just a more customizable format of what we would have to type out manually. So we would have to in this case here, imagine it being more complex, but this is the equivalent of saying, you know, so variable text, and then you would have your, what is the capital city of country, okay? And so where country is effectively the variable, dynamic variable that is going to be passed in from a user's input. So that can come from the front end, or it could be a request to the back end, however you want to do it. This is how it would typically look like. So that's the equivalent of what's going on here, except you're passing this template in to this object, and you have this country here as what is variable, right? And now we can pass in the country. So in this case, we're going to pass in France. And if we run through this, you'll see that, let's just do that second. So let's npm run start. I'm going to upload all of this to GitHub so you can play around with it. Let's see what happens now. So this format, what it does is it formats the prompt given the input values, right? So if I change this to Scotland or Spain, then it would be, what is the capital city of Scotland or Spain, okay? So effectively, this just shows you the format of the prompt, and you can see how, you know, this, when things get a bit more complicated, this would be very useful. So let's jump to the few shot case. So what's a few shot prompt? Well, few shots is just basically examples you provide to the large language model to help it generate a better response. So for example, let's say you wanted to you wanted to give context on different countries and capitals so that you want the model to have a pattern to use in its response. So you're still going to ask it the same question, then you provide these few shots or these examples to help it have a better response. So in this case, we're providing these examples, so United States, Washington, D.C., Canada, Ottawa. And then we have a formatted template, which is effectively what the template is that we're going to pass over. And then we have the example prompt. So again, you can see these are variables that are going to change, right? Because they're going to come from these examples here. And this is the template that we created here. So remember, this is the same as what we had here, right? With this prompt template that basically just outputted something like this. Basically, what is the capital city of France, right? Once we formatted it or saw the format. So we're doing the same thing here. We're making this thing here so that we can input the country and the capital. And when we console.log, we get country, United States, capital, Washington, D.C. Obviously, I'm formatting using these examples here. So you can see how it effectively just inputs into those gaps there. And now this creates an example that we can use. So finally, we create an object. So this is a few shot template object that we create an instance from that LangChain provides. And these are, you can read through this later, but basically you can provide prefix, so what text do you want to go before, what text do you want to go after. And so effectively, you will end up with something like this, where you have, you can see what is the capital city of the country below. So this is what the actual text will look like. So let's hop over to maybe a format that will make more sense to you. And this is what it would effectively look something like this, right? What is the capital city of the country below? And so in this case, we are providing these things called the few shot examples. As I said, they're just examples to help the model. But it knows anyway once it sees the pattern of country capital, you provided France as a country. And now if I just press submit, it should say Paris, okay? So this is how you use few shot prompts, by basically providing your question or your prompt and then the few shots. But in the case of JavaScript and LangChain, you can use these few shot prompt templates, which effectively take your examples, which you provided earlier, the example prompt, the prefix, the suffix, and help you to effectively scale this, because this can get very, very, very tedious. So that's few shots and prompts. Okay, cool. So let's move over to chains. So this is a basic chain. Now, if I hop back over, or rather, actually, let's start with agents, because that's a bit more exciting and also a bit more requires a bit more thinking about. So what is an agent? So an agent you can kind of think of as a personal assistant that uses the large language model to help you take actions, and it can help you either observe or use external tools. So what do I mean? Okay, so let's start from here. So we have the user, and the user says, okay, how many countries are there in Africa to the power of 3? I know this is a crazy example, but just kind of stick with me here. So they send this question to OpenAI, for example, the model, and the model basically speaks to this agent or this bot, and the bot thinks to itself, well, I need to find each country in Africa and add them together. So that's the first thought that this bot has. Now, it then goes and uses something like a SERP API, which is a real-time API to access Google search results, performs a search action to find all these African countries based on live results, and then maybe finds an article that gives a credible article that concludes the observation that there are 54 countries in Africa. Then the bot says, well, okay, now I need to calculate the total number of countries in Africa to the third power. So that's what it's thinking. And then it uses another tool to do calculations. This time it's taking a calculate action. It observes this number. It thinks to itself, now I know the final answer, and this is the final output. That is, this number is the number of African countries to the power of 3. Okay, so there's different components here. There's the user, there's the model, there's the agent, there's thinking, there's tools, there's searching, there's actions, there's observations, and then there's the final output. But in essence, all it is effectively is a sequence of interacting with the large language model for instructions, and then interacting with third-party tools to get whatever outcome you're looking for. So let's jump into the code. Okay. So I'm not going to run this one here particularly, because you can just get a SERP API, free SERP API API key that you can test this with. But effectively, again, we initiate the large language model, we initiate the tools. So we got the calculator and SERP API. So LangChain provides tools that you can use. There are many, many more. So if I just hit here, you got Bing, dad jokes, IFTTT, where you can connect to third-party tools and so on. And then you got agents here. Now, this agent is going to take the tools, the model, and this framework. You can change this and read up on it. It's just a framework that kind of goes through this kind of pattern of thinking that we describe, where it has a thought and then a follow-up observation and so on and so forth. Then you have the input. What are the total number of countries in Africa raised to the power of 3? It executes and calls, and this is kind of what the final result looks like, right? So there's a lot of use cases that we can think about here. Besides search, interacting with your calendars and, going to do maths and then taking that data and interact with other tools. But the use cases are immense when it comes to agents, LangChain, and external tools. All right, let us jump into memory. Okay. So what's memory? So memory is just basically giving the chatbot the ability to remember previous conversations. If you remember, one of the big challenges is when you're interacting with these chatbots or you try and make your own chatbot, they don't have extensive memory and sometimes no memory. So imagine you ask a question and then you ask a follow-up question, but it doesn't have context. The response is not going to be great. So what we want is to give the ability to take previous conversations into context for future conversations, but to do it in a pain-free way. And LangChain gives us the ability to do that. So here we are effectively where we're saying, we initiate this buffer memory class. We create the new object called memory, a new conversation chain. Again, LangChain has these components in different libraries, and this library is free. Then you call with the input, hello, I'm John. So this is the user basically saying, hi, I'm John. You get a response and so on and so forth. So let's run this so you can have a feel for what's going on here. So let's clear that. So npm run start, and I'm going to run through memory basic.ts. And so effectively what's going to happen is I'm going to say my name. It's going to say hi. I'm going to ask it what my name is, and it's going to respond. There we go. So, hi, John, I'm an AI. Nice to meet you. Can I ask you something? What do you do for a living? And here I go, what's my name? And the chatbot says, your name is John. So it remembered that my name is John. And I try to just put this in diagram. By the way, this image will be available for you to use and review after this video as well. But like I said, gives the chain or agent the ability to remember information from previous conversations. So you got the input from the user, the previous chat context, and then that is packaged into an instruction or a prompt in a structured way that LangChain helps you to do behind the scenes. You pass that over to the model and you get a final answer. So what's pretty cool about LangChain is all of this is abstracted and you don't have to worry about figuring all this stuff out yourself and how to structure the prompts or what prompts to use, and so much complexity going on under the scenes, especially in terms of structuring, has been handled for you from the library. So let's talk about indexes. So before we jump into indexes, it's important to understand the concept of embeddings. And what is an embedding? I'm going to do another video on embeddings and how to work with effectively the language of the computer or the language of the large language models, and when it comes to interacting with documents, because that's really the goal behind this channel, is how do we build applications that help to interact with data. So one of the things is that these models are very much focused on numbers, right? They don't necessarily understand text per se, in the sense that they usually, under the hood, convert to numbers that they can use. And this is particularly important when it comes to embeddings, when it comes to Q&A with documents, chatbots, because effectively what you're doing is you are converting the query or the user's query into text form, into a number of vectors like this that you pass over and store in a place called a vector store, where the vector store already contains a bunch of these for your document. And so it's actually matching these numbers against the existing numbers to then decide which ones are similar. It gives a similarity score using things like cosine similarity, which I'm not going to get into right now. But in a nutshell, embeddings is just converting text into numbers in a way that large language models can easily talk to, and we can easily do analysis to compare, find similarities and keyword analysis and so on and so forth. So that's pretty much, you can think of an index as a collection of this embeddings, these vector stores, and the process of getting to that point. So here we can imagine we have your PDF, then we load the docs into text, right? And then we take that text, we may split it into chunks because it's too big, as we spoke about. But what's cool is LangChain handles this for us. We create these embeddings using an embedding function. So OpenAI provides an embedding function that we can use to effectively convert all this text here into these numbers that we can then store and we can then retrieve later down the line. So let's jump into code and see what that looks like. So here we have embeddings. And like I said, you can grab OpenAI. And here we are creating a function where we are embedding the query hello world. And we get a response, and we also embedding documents. So a document from LangChain's point of view is simply just text and metadata combined together. So what I mean by metadata is just description or something useful to know what's about that particular text they can use to retrieve later on. So let's clear this out. Let's npm run start. And we want to run here, which is indexes, okay? Indexes.embeddings.ts. And so this is us creating embeddings using OpenAI's embeddings function. You can see, like I said, LangChain provides that. I just want to show you what it looks like in real time. So you can see that we've created these numbers, as I said. So literally these few words have created 1,000, each vector has 1,536 dimensions. So that's what we're dealing with here. And so you can see all these numbers. So you can imagine if I did a search or query, what would happen is, if you had a large document that you had already embedded, we would embed the query. So the query could be hello world, and then we would compare the vectors, the numbers, to the numbers already in storage, and whatever is in storage that is closest to hello world is what is is what's sent back. So that's how it works, but I'll go more into that in detail in a different video. Here we have a document loader called recursive text splitter. And like I said, these are just useful, super useful tools that you would have had to figure out the logic yourself previously, but LangChain provides facility for that. So in this case, if I just clear here, I run, you can see this is the text, and then I can just do recursive text splitter.ts. And by the way, I want to give major credit to ideas behind this. This is actually a huge fork from LangChain's example repository. So I just made a few tweaks, but a huge shout out to the team there for this. So please make sure to check out what they're doing. I'm going to leave their docs. You can join the Discord. I'm part of the Discord as well, and it's just a great, a lot of innovation going through. So please check out what they're doing, support it, and get involved as well if you can. So you can see here we create these documents, as I said, contain page content metadata. But the key point here is you see we split this into different chunks, right? And here we defined we want it to be 10 characters per chunk, and each overlap between chunk would be 1 character. So this is what this thing called the recursive character text splitter can do for you using LangChain. Now we have the vector stores. Now, what happened here was I already ran through this function. You can run through it yourself, but what I ran through this function to store this text here. So it's state of the union text speech. So this is how it would typically look like in real time. You would have your text, already ready to go. And then you would have the vector store. So we would load the text, load the model. Now we're going to use Pinecone. Pinecone is a vector store. So remember the diagram where we store the embeddings. So we're using Pinecone. There's others like Chroma and Weaveit and Fize, and there's all kinds of other ones. But for this example, we're using Pinecone. So you need to go, and Pinecone is free. You can sign up and create your own vector base. I'm going to put instructions for you to do that. So I initiate that. I load the file. Then I split, as I showed you previously. I'm splitting into chunks of 1,000 characters. Then I create a document object. This is the index I created on Pinecone, which I'm getting. I embed these documents, running through these functions, and there we go. So I'm not going to run through this again because that's going to override what I have. So you can run through this and see what happens. Obviously, make sure to change this because this is mine. But effectively, what we're doing here is loading the document and storing it in the vector base as per the diagram. Now, speaking of document loaders, you also have a lot of choices here. So you can load. You can literally scrape websites. You can Hacker News, IMSDB. You can load documents. So there's loads of documents, and every day or every week, you have people effectively making pull requests to add more. But here we have an example of a text loader. So it takes a string, a file path string, and then it loads it. And here you see the example data. This is an example data to see how LangChain loads raw text, and that loader led to this output here. So I'm not going to go through that again, but I'm just showing you what the output looks like when I ran through it the first time. Let's clear this here. Cool. So let's jump into, so we've gone through a basic chain. Well, actually, we didn't go through a basic chain. So yeah, this is just a basic chain. I think we went through very similar to the previous example with the prompts, where we're just chaining the template, the prompt template, with the large language model. So you can see, you should be familiar with this now. Then we create the chain. So the large language model chain, which is a combination of the model and the prompt. We ask what country is it, France, and it says Paris. We can also have conversations as well using the conversation chain. So let me play around with this. So start, and we are going to go with conversation.ts. So here we go. So again, we initiate OpenAI. LangChain provides a conversation chain, which also includes prompts that you don't have to worry about yourself. And then we have the chain.call. And here you see, hi, I'm Jim. Hi, Jim. It's nice to meet you. My name is blah, 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 blah. How can I help you today? And you have another response that comes through when I say, what's my name? So you said your name is Jim. So similar to the memory case, I'm just showing you how it turns into a thing called a chain. Summarization, obviously very useful. So in this case, it's just a simple case of using loading. Again, LangChain provides utilities for all these things. But here where, I just did a short text. It could be longer. It could be a document. Whatever it is you want to do, you load. In this case, I'm using analyze document chain because it's a small piece of text. But if I had chunks, I would use a different chain. Again, the docs are very, very useful for this. And you call, and then you get a response like so. I'm not sure there's any necessity to run through this, but I think you get the gist anyway. So I'm just going to pause on that. So here we have a question answering. So we got a question answering situation where you have a document here, which could be much, much more than this. But Rachel went to Harvard, Tom went to Stanford. This is effectively what it looks like. As I said, it contains page content and optional metadata. And I'm just going to run this so you can see what's going on. You can see the call, the chain call, it takes the docs and also the question, and it passes that to the model as well. So let's see what happens now. So we ask the question, where did Rachel go to college? And we get the response, Rachel went to Harvard, which the text did say Rachel went to Harvard. Cool. Let's jump to the final example, I believe. And this is where it gets very interesting. Now, before we jump in, I just want to say that there are some useful utilities here. And what I'm trying to do here is just kind of, I guess, break down the magic behind it. It's not too much, but it's just the basics of what's going on. So you embed in a query, you effectively embedding using this function called embed query, similarity vector search. So again, this is where we want to look at what it's currently in the vector store and compare to our query. And the closer the numbers are in terms of similarity scores, then that's what we want to get back. And so again, you can just view this lib to just have a feel behind the backend logic. And again, much credit goes to the LangChain team for inspiration for this. But let's go back to a final example. And it's what really the magic begins to stand out. And this is where you start to Q&A document. So what's going on here? So effectively, we have Pinecone. We're initiating as the storage. We have the just cross-checking that the particular index that we're index being the store that has our data. Again, this index has been preloaded with data from that speech that I showed you earlier that was in the large text. And this is the query. So the query is, how many new jobs did the economy create? Let's go and verify. So if I do Control F, job created. So this, you can see it says, let's see, jobs. In fact, our economy created over 6.5 million new jobs just last year. Okay, so you can see this is a large body of text. There's a lot going on. So let's jump back and let's see if we can get a useful answer from this large document. So we're going to call vector DBA chain. Again, don't follow this syntax too closely because this is almost like a custom function that I made that I showed you previously. But all it's effectively doing is taking the query, it's taking the index, which you saw earlier. So it gives you the operations, typical CRUD operations to create, read, update, delete. The namespace, so what's the namespace where the vector is stored, and how many results do you want to return that are similar. We pass all of that, we run through a vector search function, and we do some other stuff. Nothing too crazy. But here we're just focused on first principles. So effectively, we run that chain, which includes the large language model, the query, the index, the namespace, all the things you can imagine would be necessary, including prompts provided by LangChain to structure and to try and find the relevant information. So let's clear this. And if I just go to question answer docs.ts, so let's run this. So this is the question, and let's see what the response will be. So hopefully, fingers crossed, we end up with something like that. Let's see. Is it going to figure it out? Oh, there we go. We got the answer right here. Over 6.5 million jobs. And what's pretty cool is now let's run it back. Let's see what's going on. So what's going on, you can see we have vectors here. We're splitting the text. Then we've got, so now we've got the results of the similarity search, which was in that inside this function here. You can see this is, each vector has an ID, a score, metadata, which contains the text. You can see that this snippet of text, which was a chunk that we split initially, is the most similar in terms of vectors to this question here. And that's why it was the first one to show up, because these are the vectors of this query. And these vectors, right, which are 1,536 dimensions, were compared to the vectors in the database, and it found that ID 11 was the most similar. So this is the text, and then ID 17 was the second most similar, and so on and so forth. So that's how the vector similarities work. And so we keep going down, 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 down. And you can see just more stuff going on. But eventually we land with the final response. We pick the top scoring one. We pass that over to, you can see this is the template provided by LangChain that I did not have to write. Use the following piece of context. If you don't know the answer, just say you do not know. We pass that as context. Then we ask the question, which was here, and then we leave a gap for a helpful answer, and voila. So that's how it works in a nutshell. It's not too crazy, but it's very exciting, very interesting, and yeah, effectively everything that you would have had to abstract for yourself, figure out the prompts, the structures, how do I extract data, how do I, effectively integrate different tools with the large language model, how do I scale my application, how do I make it more cost effective. LangChain is really working on that. So I hope this video is useful for you as a TypeScript, JavaScript developer, because there's not much resources out there for us to build this stuff. But I believe as the ecosystem keeps growing, it's going to get better. So if you have any questions, just hit me up in the comments, and that'll probably also give me good ideas for the next video. Cheers.